Okay, today we're going to talk about the composition of inverse functions. So we learned last week that inverse functions are things that are opposites of each other. You switch to x and y and solve for y. So there's a way to test whether or not something is an inverse by looking at the composition of the two functions put together. Alright, so that's what we're going to be doing today. Excuse me. Let's see if it'll change. Okay, so the property says if f of x is equal to, or if f of x and g of x are inverse functions, then f of g of x should equal x and g of f of x equals x. This just means that no matter what order you do it in, whether you plug f into g or g into f, you should end up with an answer of x. If it's not x, then that means that the two are not inverses. Okay, so copy this, or fill in your notes in the blanks and copy that down. And we're going to work an example. Okay, so anytime I ask you to determine if something's an inverse, you know you're going to do f of g, of x. That's a g. Okay, so I'm going to take g of x, because we already know what it's equal to, and I'm going to put it in for x over here. So I'm going to have 4 times x plus 6 over 4 minus 6. Now, if I simplify this down and it equals x, that means that my two initial equations are inverses of each other. So to do this, the 4's would cancel out, so I'd be left with x plus 6 minus 6. The 6's would cancel out, so I'm left with x. So that means that f of g of x is equal to x, so yes, they are inverses of each other. Okay, so basically, if I had switched to x and y here and solved it down, my answer should be this. If I had switched to x and y here and solved it down, my answer should be this. They should be opposites of each other. Okay, if we were to graph them, they should be reflections across y equals x, just like we did when we graphed in that packet from last week. This is just a faster way to figure out if they're inverses, if you already have two equations. Alright, let's try another one. So we're going to do f of g of x. Okay, this is g of x, so I'm going to plug it in for this x. So I'm going to do 1/4 times 4x plus 4 minus 1. Now I'm going to distribute the 1/4, so I would end up with 4x over 4 plus 4 over 4, that's a 4, I don't know what that extra line is, minus 1. Alright, these 4's cancel, I'm left with x. 4 over 4 is 1 minus 1, those would cancel, so my final answer would just be x. So that proves that, yes, they are inverses. Okay. Now, if I had gotten something other than x, then all you would write is no, they're not inverses. And you'd move on with your life. Okay? Let's work a third example. So it's determine if the functions are inverses. So let's do the same thing. We're going to take g of x and plug it into f of x. So we're finding f of g of x. Alright? So I'm going to take the square root of x plus 1. Now, whenever you insert something, you should put it in parentheses like that, and then I'm going to square it. Well, we learned last week that when you square a square root, this goes away. So I'm just left with x plus 1. Now, this 1's not going to go anywhere. There's nothing to cancel it. So this would be your answer of them composed together. So this would be f of g of x. So because this does not equal x, they are not inverses. Okay? So we use composition of functions to determine if things are inverses because it's fast if you have two equations and because it's an easy way to check. And it's a skill that kind of gets you used to composing two equations together. Okay? Compositions are used a lot in calculus. In pre-cal you use them occasionally, but mostly it's in calculus. Okay? So make sure you took a note of this. Make sure you filled in your notes on your worksheet. And I will see you tomorrow.